Okay, so let's talk about completing the square. And we're going to use this to convert from standard form to vertex form. So first let's do a little algebra review. So we are going to talk about perfect square trinomials. I know that if you had me, you knew that I went over these all the time and told you that it was really important that you remember and memorize the formula. So the formula for a perfect square trinomial is x plus y squared equals x squared. Sorry, I'm having problems with my computer today. X squared plus 2xy plus y squared. So we're going to take this formula that we know how to factor perfect square trinomials, and then we're going to create them to get into vertex form. So a trinomial of the form ax squared plus bx plus c, where b divided by 2 squared equals a times c. So we're going to factor the following trinomials. X squared plus 8x plus 16. If we factored that, we would get 2 factors of x plus 4. So we can just write that as x plus 4 squared. We can also notice that it fits our formula because b in this case is 8, divided by 2 is 4, squared is 16, a is 1, c is 16, so a times c is 16. We can also look at it as, in this formula, is that x squared would be 1, or y squared would be 16, so the square root of that would be 4 times 1 times 2 is 8. Alright, so let's look at a squared plus 2a plus 1, and that factors to a plus 1 squared. M squared minus 18m plus 81 factors to m minus 9 squared. And p squared minus 10p plus 25 factors to p minus 5 squared. Alright, so to convert between standard form and vertex form, we have to complete the square. So if the standard form equation is a perfect square, like example 1, then we simply factor to convert to vertex form. If not, then we're going to use a process called completing the square to write the equation in vertex form. Step 1 is that we're going to group ax squared plus bx. And step 2 says if a is not equal to 1, we're going to factor it outside so it becomes a with x squared plus bx. We will also do this if we have a negative. We're going to factor out the negative. We're going to complete the square by taking half of b and squaring it. This is the new c. Then we're going to add this to x squared plus bx. This is the perfect square trinomial. And then we're going to subtract a times c from the end of the equation. So if it's a negative that we're pulling out, we need to make sure we remember that we're going to multiply that times c and then subtract that from the end of the equation. Then we're going to factor the trinomial and simplify the end of the equation. So I know that's a lot of words, let's go through these and I promise it's going to be a little bit easier. So let's do number 1 together first. So the first thing that we're going to do is we're going to group ax squared plus bx. This computer. Alright, so we're going to group x squared plus 4x. Okay. And then put this side here. Then we're going to take half of 4, which is 2, square it, which is 4, and we're going to, and then we're going to add that, plus 4, and then subtract it from the end here. And this is going to factor to f of x equals x plus 2 squared, and then 4 minus 4 is just 0, so we're done. Which means that our vertex is the point -2, 0. Alright, let's do this for number 3 as well. So we're first going to group it. And then minus 5 is out here. And then we see that we have a negative, so we're going to pull that out. Alright, then we're going to take half of negative 6, which is negative 3. We square it, becomes positive 9. We're going to add that to this, and then we're going to multiply it times our negative, which is negative 9, and we're going to subtract a negative 9, which becomes positive 9. And then we factor it and simplify. So we get negative x minus 3 squared plus 4. So that means our vertex is at the point 3, 4, and it opens down because of the negative. Let's do another example. We'll do number 5. So number 5, we have, let's group it. And so we're going to take half of negative 3, which is negative 3 halves. We're going to square it, and that's going to give us 9/4, and we're going to add that to both sides. Well, we're going to add that to this side and subtract it from this side. So then we get f of x, and we factor it, will become x minus 3 halves squared. And then we do the math on negative 2 minus 9/4. We're going to get negative 17/4, which means our vertex is at the point 3 halves, negative 17/4. Alright, let's do number 9 together. Alright, so number 9. The first thing that we're going to do is group it, but let's also just pull out that negative 2 from our group. And leave a space. Okay, so then we take half of 10, which is 5. We square it, which is 25. And we add that to both. We add that inside here. And then we take 25 times a negative 2, which is negative 50. We subtract that, so minus a negative 50 would be plus 50. And then that means that this is to negative 2 x plus 5 squared plus 4. So our vertex is at negative 5, 4. Alright, so now let's put it all together. We're going to convert to vertex form. We're going to identify the vertex, the axes of symmetry, and then we're going to graph our parabola. So let's look at number 11. We have, let's group our dx, x, leave a little space, plus 39. Half of 12 is negative 6. We square that, it's 36. We're going to add 36, and we're going to subtract 36. Then when we factor it, we get x minus 6 squared plus 3, which means our vertex is the point 6, 3. So we put that value in the middle, and then we're going to pick numbers on. So when we put this in, we get 5 minus 6 is negative 1 squared would be 1 plus 3, give us 4. 4 minus 6 is negative 2 squared would be 4 plus 3 would be 7. 3 minus 6 would be negative 3. Negative 3 squared is 9, plus 3 would give us 12. And then we know it's just a reflection on each side. So let's graph our vertex. 1, 2, 3, 4, 5, 6. 1, 2, 3. We know it's opening up. Alright, and then it's just a reflection on the other side. So there's our parabola. Alright, let's look at number 12. So, we're going to rewrite it. And then we're going to pull out that negative 3. Okay, so then we have half of 4 is 2. Square that is 4. So we're going to add 4. And then we're going to multiply 4 times negative 3, which is negative 12. And we're going to subtract a negative 12, which becomes plus 12. Then we can factor this. So it becomes negative 3 times x plus 2 squared plus 4. So our vertex is at the point 2, negative 2, 4. So we're going to make that our middle value, and then we'll pick values on either side. Alright, so let's start with negative 1. If we put that in, we get negative 1 plus 2 is 1 squared. It's still 1 times negative 3 is negative 3 plus 4 will give us 1. 0, we're going to get 2 squared, which is 4, times negative 3 is negative 12. Negative 12 plus 4 is negative 8. I think I did this wrong. Wait, let's see. So negative 1 plus 2 would be 1 squared times 3, 4. That's 0 though. So we're opening down. So we have negative 2, 2, 3, 4. There's our vertex. We're opening down. Oh yes, so it makes sense. At negative 1, we are at 1. At 0, we are at negative 8. Yeah. Alright, and at 1, we'll have 1 plus 2 is 3 squared, which is 9 times negative 3 is negative 27, plus 4 will be negative 23. And then we just have a reflection. Alright, and that's complete the square.